Why did I start it now? Okay, so for 1 day 2, we're going to work on graphing that inverse function, that reciprocal function. And so we need to know what an asymptote. An asymptote is a line that a graph approaches but never touches or crosses. Okay? An asymptote, asymptotes guide the end behavior of a function. Those are the things you need to know about an asymptote. That is important. They are imaginary. So if you want to write imaginary in front of line, okay, there are horizontal, there are vertical, there are slant. So there are asymptotes, all different kinds of asymptotes. Vertical asymptotes cut the graph in pieces. Horizontal is the end behavior. So specifically, asymptotes guide horizontal. Guide as x approaches negative and positive infinity. Vertical do a lot of things. Vertical do a lot more. But horizontal, their specific is what is happening out here and out here. Nothing really in the middle. Do you have the top written so I can keep talking?
Does that say no. X?
X approaches, it's an arrow.
Yeah, write the graph.
Okay.
Is that a plus infinity sign?
Plus and minus. I tried to write it small, I should write it bigger. Now, what I just did is paraphrase what all the other words are, okay? So if you wrote what I did with the horizontal plus and minus, approaches infinity, you've got what the others say, okay? It says, as x approaches infinity, f of x approaches 0. You see how this graph is approaching 0? Okay. Both as it approaches positive infinity and negative infinity, this graph is approaching 0. It will never touch 0. Okay? It will never cross 0. But there's a but. Remember I said horizontal only out here and out here, right? If I had an x-intercept right here, the graph could cross on a horizontal. But on a vertical, it never happens. If there was one right there, I should have a different color besides red. If there was one right here, it would come down and then come back up towards that asymptote like this. Asymptotes are like magnets. They draw the graph close to it. It never shoots away from an asymptote. It will eventually approach it. So y equals 0 is a horizontal asymptote, and x equals 0 is a what? Vertical. So we have horizontal, and we have vertical, and we will have slants eventually. And it could even be like this. And we'll work on that. So, graph the function y equals 10 over x. What is the domain, range, and asymptotes of the function? Okay, asymptotes. I need to go back here. Asymptotes, you can easily find them. Vertical asymptotes. Yep, we talked about it right here. I guess I didn't point out. Are when the function is undefined. So when is a function undefined? What is the one thing you can't divide by?
0.
So these reciprocal functions are going to be undefined when you try to divide by 0. You guys got that on the vertical asymptotes before I switch back? Carly and Kyson are sorry. Kyson, you good? Okay. So we have y equals 10x. So the things I'm going to, darn it. You have to have arrows on your positive and negative x-axis. Have to. Okay?
Does it matter how big the graph is?
Ew, that's horribly not straight. Does it matter how big the graph is? You need to have it big enough you can see what's going on.
I did that good.
You will get to the point with about 2 of these problems fit on a page. Yeah, that's fine. Okay, so, well, the only place it's going to be undefined is where the denominator is equal to 0, right? So you set vertical asymptote, otherwise known from here on till the end of infinity to VA. VA stands for what? Okay, you set the denominator equal to 0. And solve. Otherwise known, find the zeros of the denominator, correct? Yes? Isn't that the same thing? Yeah. Okay, so what is my denominator? X. My denominator is x. So x equals 0. So where's my vertical asymptote?
0.
X equals 0. And you have to say x. So x equals 0 is a vertical asymptote. So I will go to a different color. So when the asymptotes land on the coordinates, the coordinate plane, I kind of make them slanted like this. Because I know I'm going close to it, but I can never cross it, right?
How did you get x equals 0?
I set the denominator equal to 0. The denominator is x. So x equals 0, it's 0. There's nothing to do. So if I had 2x minus 4, I would add 4 divided by 2, and it would be 2. Get what I'm saying?
Yeah.
Okay, so I have the vertical asymptote. All good? Okay. Now, we need to figure out the horizontal asymptote. And we can do that by plugging in some numbers. But first we're going to do something. We're going to do something called interval analysis. I'm going to spell it wrong. Who's going to spell for me?
No, I'm in.
I will spell.
KNALYSIS.
Thanks. Okay, interval analysis. My brain was not there. I couldn't spell. I tried to spell join earlier, and I wrote it, and I'm like, that's not right. What's wrong with it? Like, I can't even think. Okay, so interval analysis. Intervals are made by vertical asymptotes. So I start over here at negative infinity, and I'm walking across my x-axis. This little guy walking right here. See him? Can you picture him?
Yep.
He's whistling, singing. And what's the first thing he stops at? What's
10.
Not 10.
0.
0. Is my vertical asymptote going to be a problem? Yeah. I call them fences and potholes because we'll have potholes too. Okay? I got to do something with this fence, right? I got to get over it. So I'm going to go in an interval from negative infinity to 0. And I'm using parentheses because 0 is not included and I never can get to negative infinity. So then after I climb the fence and get over it, I start at the other side of 0, right? And is there any obstacle? Nope. So I get to go all the way to where? Positive infinity. So what interval analysis does is we pick a point somewhere between negative infinity and 0 and somewhere between 0 and positive infinity, which you guys have actually already done, and you decide whether you get a number that is positive or negative. So if you put in an x, you get out a y, correct? Okay. So if I have a positive x, I'm above the x-axis, yes? If I have a positive y, excuse me. If I have a negative y, I'm where? Below. So pick a number somewhere between negative infinity and 0.
-5.
-5. Okay, so what I do is I put -5 here so I know what I plugged in. And I do not care what the answer is most of the time. But in here it will help me graph, but I'm going to just do it. Okay, so it's -5, so I have 10 over -5. Or I have a which is going to be what?
2.
-2, okay. Or I have a positive over a negative. Yes? And a positive divided by a negative would be a what? Negative. So that means the graph over here is somewhere down here.
Yep.
See that?
Yep.
So then I'm going to pick a number between 0 and positive infinity.
1.
1?
Yeah,
You're boring.
I agree.
Okay, 1. And you write it down. So that gives me 10 over 1, which is 10. Or a positive over a positive, which is a positive. So the graph is somewhere up
How
there.
do we know if it's going to be on the other two?
Huh? Well, positive, the only, between 0 and positive infinity, the only place positive is up there, isn't it?
So only got to worry about those two?
What?
So only doing those two?
Mm-hmm. The graph is only going to be in those two quadrants. Unless there's a 0. Well, how do I find a 0 again? How do I find an x-intercept? Plug the y as what?
0.
0. Isn't every single x-intercept the y 0?
Yeah.
Yeah? See how we're using everything we've already done before? Okay, so I have, I'm running out of room, 10 over x equals 0. Yes? So we're looking for the x int. I should have labeled my work, yes? What's x int stand for? X-intercept. So 10 over x equals 0. Well, how do I solve this? I multiply both sides by x, right? So it reduces on the left, and x times 0 is what? 0. So can 10 equal 0?
No.
Not without a variable. So is there an x-intercept? No, there's no x-intercept. So since there's no x-intercept, I can't cross from this negative up to the positive, can I? There's no door. And I already put in an interval, and I know it's down here somewhere. So it's going to be looking like what? That. And this one here is going to be looking like that. Now, we did find a point. We found when we plugged in -5, we got -2, didn't we?
Yeah.
And we found if we plugged in 1, we got 10.
Yeah.
So we could graph those points. We could make a table. But do we have the idea what this looks like? Yes. Now, I am going to tell you there is a horizontal asymptote at 0. Okay? And how you do that is, what's the degree of, is there an x in the numerator that you see? Is there an x in the numerator? No. So if there was, it would be 10x to the 0, yes?
Yeah.
And x to the first in the denominator. So for horizontal asymptotes, and we'll keep working on this, I'm not going to give you the whole list yet, you compare those degrees. So 0 is less than 1, yes? So anytime the degree of the numerator is less than the degree of the denominator, guess what you're going to have for a horizontal asymptote?
0.
0.
How do we find the domain and range?
Okay, we're going to get there.
You're
Okay.
not there yet?
Nope. I'm not going fast. I'm going slow. Okay, so domain. Domain are the x's, yes?
Yeah.
So x such that x, what is the only x that this graph cannot be?
0.
0. So x can't be 0.
Is that like that for all of them?
No, because if we moved it left or right, that would change. That horizontal asymptote, it's going to be the horizontal asymptote.
But I thought it
Okay.
was going to be 0.
Huh? It can't be 0.
So the horizontal.
So the horizontal asymptote is always going to be not equal in the domain. Always. Okay, range. What can't it, y it equal? 0. So y can't equal 0. I will tell you as we get further and further and further, I will only ask you about domain. Because of the fact is if I know the range, if I know the domain, I'm going to know the range, right? Because the range comes from the domain. So as you get further on, I don't even ask you about the range. It's just these basic ones that you can see the range. Now, do you all have your calculators? Yes?
Dead.
Or maybe you need to charge it. Huh?
I did charge it.
We did it. We have the asymptotes. We have vertical asymptote and horizontal asymptote. And we have domain, range, vertical, horizontal, and graph. Okay. So we're going to put this in your thing. Why is it in your locker? Just watch. You can look up on here. If I put this in my calculator, it's y equals 10 over x, right? So you write 10 divided by what? X. And if you haven't used your calculator in a while, I'd set Zoom 6.
Zoom 6?
Yep. And did you get...
Zoom 6.
Zoom.
See it from there, Ainsley?
Like this?
Wait, how'd
You have to put the equation in. Y equals... And then you have to put 10 divided by x. And you should get something that looks like this.
10 divided by x?
But isn't that the equation we did?
No.
In the first one?
Yes.
Wait, where are you getting 10 to?
That's the problem we did. Y equals 10 over
How do you
x.
find x?
It's right there. X, T, theta, N. Right next to alpha.
And then I hit what? Zoom enter?
Zoom 6.
I bought my calculator and I haven't used it this week.
Mine's like barely hanging. Do you see that dead battery at the top?
Well, maybe you need to plug it in. Okay. Yours doesn't look like this. You put in y equals, you put 10 divided by x.
I did not put y equals.
No, you don't have to put y equals. You have to go to y equals.
Did you have it?
Yes, I had it in the thing.
No, you
It
didn't.
looks like the one.
It looks like this. Yeah, it looks exactly like the one we made.
Wow.
Look at that.
Now it does.
Good. Okay, so can you check these and look at them? Yes. Okay, right now I'm more concerned with, if you look at this, look at the picture on your calculator. Can you see that the vertical asymptote is x equals 0? Can you see that on your picture? Can you see how it's approaching x equals 0 but not crossing? You're not looking at me, looking at your graph.
Yeah.
Oh, yeah.
Yes.
Yes.
Yes, do you see it?
Yes.
So I can
Okay,
go.
so when you look at it, can you see that the horizontal asymptote looks like it's y equals 0?
Yes.
Yes, okay. So from those, could we figure out our domain and range? Yes.
Yeah.
Okay, so I want you to try to sketch them, but second resort is what?
Calculator.
Calculator. We will get to the point that we are doing every single thing. There's like a 10-step process, and we go through everything in order, the same order every time, so you don't forget without a calculator. But right now, I want you to see, like today, I want you just to see it. So try without, but what should you do to verify? Check. Okay, so let's go to another one. Okay.
Okay, I'm just watching.
Yeah, you can just watch. Nothing wrong with that. We need to graph 1 over x minus 3 plus 2.
Oh, God. Don't you set it to 0 first?
Well, I don't like the plus 2. Do you guys like the plus 2? That's like, we need to probably put that into one thing, don't we? So we need to get a common denominator. However much we don't like to get a common denominator, we're going to have to. So our common denominator is going to be x minus 3.
Miss Wade, what does this G in the parentheses X mean?
It's just the name of a function. Like f of x, g of x, k, l. Nope. Nope. Just the same thing as y. So our common denominator is going to be x minus 3. So that means I need to multiply 2 by what? X minus 3. So that gives me 1 plus 2x minus 6.
Yeah, so 2x minus 5
2x minus 5
over x minus 3.
over x minus 3. How did I get what?
From point A to point B.
I have to get common denominators. So I have 2 over 1. So my common denominator is going to be the x minus 3. So I have to multiply both the numerator and denominator by the same thing. Now I'm going to tell you, you're probably not going to get a whole lot of problems like that, but there is one in your homework today like that. Okay, so this is what we're doing. This is what we're dealing with, okay? Right here. So the first thing you want to do x-intercepts, domain and range. Okay, what?
X-intercept. Domain and range is.
Well, domain and range we can do, but we would have to do vertical asymptote before we do domain. Well, we wouldn't have
I
to.
just want to do something first.
I like to do x-intercept first. Okay. Well, first of all, we'd simplify if we could, and we've already simplified it. A lot of people jump right now and do domain. Do you want to do domain? I'm fine. No? Okay, x-intercept. So x-intercept, remember, we set it equal to 0, right? Now, I'm going to have a quick discussion, and I don't really want you to write this down. I want everyone to watch real quick. If I set this 2x minus 5 over x minus 3 equal to 0, the first thing I do is multiply over the x minus 3, and I'm going to get what? 0. Remember when I had 10 over x equaled 0, I multiplied over by x, and I'm going to get what? 0. What am I going to get every single time I multiply? 0. So when I do the x-intercept, I really don't even worry about the denominator. I just worry about the numerator. So the numerator is 2x minus 5, and we set it equal to 0. Because the denominator, we are setting the whole function equal to 0. But when you multiply over that denominator, it's always going to give you back what? 0. So in this case, I would add 5, correct? So 2x equals 5. And I would divide by 2. So my x-intercept is going to be 5 halves, comma 0.
Where did you get 5 halves?
Because I added 5 and divided by 2.
Huh?
Right here. When did you add? I added 5. You see that?
No.
Right here. Do you see I added 5?
No.
You
2x minus 5 equals 0.
Okay, so 2x minus 5. So I add 5 to both sides. So I'd have 2x equals 5. I'm just solving 2x minus 5 equals 0. Add 5, add 5. 2x equals 5. Divide by 2, divide by 2. X equals 5 halves.
Yep.
Back to algebra 1.
I do not remember that,
Okay, so our x-intercept is 5 halves. So we know that this thing is going to cross, correct?
Yeah.
And 5 halves, we should all, 5 to 2.5, right? So we're not going to do a lot with it. It doesn't tell me to find it, but it does tell me a little bit more about the graph, doesn't it? Okay, so vertical asymptote. What did we set equal to 0 for that?
Numerator.
What?
The numerator.
Denominator. If you remember, you use the numerator for the x-intercept, you use the denominator for the vertical asymptote.
Wait, what's the interval?
We're gonna get there. It was all jumbled up before. Now I'm trying to do it in order for you. We're gonna get there. We can't do the interval until we have the vertical asymptote. Okay.
equals 0.
So we have, so it's x minus 3 equals 0. So x equals 3 is the vertical asymptote. Okay. Now horizontal asymptote,
Okay, what does that mean? Like the 3 vertical asymptote?
that x equals 3. That's a vertical asymptote at 3. 1, 2, 3, vertical asymptote.
How do you know which one's which?
What do you mean?
Vertical.
Vertical is the numerator. Horizontal is what we're doing now. I mean, vertical is the denominator set equal to 0. Horizontal.
So is numerator at the top?
Yes. Okay, remember I told you horizontal asymptotes for the degree. Yes? What is the degree of the numerator?
1.
1. What is the degree of the denominator? 1. So what's 1 equals 1, right?
1.
So when 1 equals 1, we use leading coefficients. Okay, so what's the leading coefficient of the numerator?
1.
No,
3. X.
2. What's the number in front of the x? 2. So it's going to be y equals 2. And what is the number in front of the x down here? 1. So y equals 2.
Oh, wait. Where did you get the 2?
The leading coefficient of the numerator.
Is that the big number plus 2?
Are you using not the 2x minus 5 and x minus 3?
Move your seat down.
No, you could move. You move. It would be easier for you to move than him to do that. Thank you. Okay,
Blocks it even more.
then go to another table, Ainsley.
No, I'll just deal with it.
Did you lower your seat?
Yes, I did.
Thank you
Yes, sir.
very much. We're using this version that we put together. That's what I've been using the entire time. Okay, so we have the x-intercept, the vertical asymptote, the horizontal asymptote. So what we have so far, let's put it on here. I'm going sideways again, but oh well. Okay, x-intercept is at 5/2, which was 2.5, right? 2.5. Guys, it's a sketch. Doesn't have to be perfect. I'm never going to give you graph paper for a reason. Okay? Vertical asymptote, which is up and down, is at x equals what? 3. So at 3, we draw some imaginary line, and I totally missed it, so you just make it bigger.
How did you get 2.5
From there. That adding 5 dividing by 2.
That's confusing me. I'm so confused.
Okay. That's why we're going to keep working at this. Okay. So horizontal asymptote is at y equals what?
2.
2. So 1, 2. Dot, 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 and. Okay. Now, when we get further into this, we will work on finding the y-intercept also. I would hope you know right now that this graph has to go through that point, correct?
So I couldn't go through.
No, that's a 0. That is a 0. That blue dot is the 0, is the x-intercept. Yes?
But it's not going through it.
We haven't drawn the graph.
But I thought I couldn't go through the...
It can't go through the asymptote. It's not going to go through the asymptote.
Wait, what's the asymptote?
I thought the asymptote was the purple
I thought the
line.
asymptote was the lines that were the correct...
The asymptote is these dotted lines that we drew.
Yeah.
We haven't drawn anything else.
Oh, that makes a lot of sense now,
But
Miss
it
May.
passed through the lines of the graph.
Wait till the line...
What?
It passed through the lines of the graph.
This is
though.
too confusing.
It passed through the x and the y axis, yes.
Oh, but not through the...
Yeah, we haven't drawn any graph yet. We have not drawn a curve yet. Okay,
Okay.
So the curves just won't touch that.
yes. Okay, we haven't even gone to graph yet. Okay, so when you have an x-intercept, your curve has to go through it, correct?
Where's our thing on that? Oh, is that the line? Oh, that makes a lot of sense now.
Okay, stop. Let me finish, please. When we have an x-intercept, do we have to go through it? Yes. We also know that an asymptote we cannot go through. So I can't start up here and end down here, can I? No, because there is no x-intercept, I can't do it. So that means the graph has to be all down here and then come through here and do what?
Touch that dot.
Touch the dot and then come down like this. You see that?
Yeah.
Okay. Now, this is a function, so there cannot be anything up here now. Because remember, a function has to pass the vertical line test. So there is nothing up here.
I thought there was never going to be anything up there.
There could be on a different graph, a different equation. Okay, now we have to do the next piece. We have to decide whether it's going to be up here or down here. Now, is there an x-intercept on this side? No. So if I had an x-intercept, it would have to do the same thing the left side did. So is there a door to come through?
No.
No. So is the graph going to be down here?
No.
No. The graph has to be where?
In the other corner.
Up in the corner, because I don't need no doors up here, do I?
I thought the line couldn't go through the asymptote.
It didn't. There is not one line that went through an asymptote.
Through that, oh, never mind.
No.
I'm a little confused.
There is no line that went through an asymptote.
Why can't it go through the bottom? You said a door, but what?
A door, an x-intercept. There is no x-intercept over here where I'm erasing right now. So if there is no x-intercept, I can't, what did I say an asymptote was like a magnet, correct?
Yes.
Okay, it's like a magnet, so that means that I have to, I'm trying to find different colors. I have to go next to this one, and then I have to get next to this one, yes? Do you see that? But do I have an x-intercept to be able to do that? Do I have an x-intercept over here?
Yeah,
No.
Do I have an x-intercept over here? So can there be any graph over here?
No.
No. Now, we didn't do an interval analysis, but if we did one, we would get plus, minus, and guess what again? Plus, because we are positive, negative, positive. That means above, below the x-axis, above the x-axis. This is a procedure, and you have to go through the procedure. You don't look at this right here and say, oh, that's what it looks like. Doesn't happen. Doesn't happen for me, and I've taught it for 18 years. How do I check if I'm right?
Your calculator.
In your calculator, you do not have to put this one. In your calculator, you will put the original problem. You will put 1 divided by parenthesis x minus 3 plus 2. If you're me, I put an extra parenthesis around all that, but you don't have to. In the y equals. When you do that, you should get something similar to what we have.
So on the top, for Y1, do we put this one?
Yes.
Miss Mick, how do you know which ways your arrows are going?
It goes left to right. There's arrows on both ends, but I go left to right. Okay, did you get something similar to what we did?
Yes, I did.
No.
I did.
Mine has a giant line going up.
That's your asymptote.
Okay.
Mine
The newer
says-
one does not show the asymptotes.
Mine says air,
You didn't put it in right.
and it looks like this.
You didn't put it in right. You have to put it in exactly how I wrote it up at the very top. And
Wait,
you have to
that's
make
how
sure
we got-
nothing
So
in there.
How do you do that?
this problem's done, right?
Okay, now, when you look at your graph, or hopefully you can look at somebody's next to you, do you see those asymptotes? Do you see the asymptote at 3? I mean, the old calculators, you visibly see the asymptote at 3, right?
Yeah.
Okay, but do you see the horizontal asymptote at 2? Do you see on your graph that it's kind of approaching 2 horizontally?
Yes.
Yeah.
Okay,
I was near.
are you okay?
Yeah, I was near. I just fell.
You just fell?
Yeah.
Gravity had the best.
I was sitting like this.
And you just fell. The floor tilted. Okay. So, again, this is a process that you will go through and you're going to work at getting them. Does that make sense? How did I find vertical asymptotes? Oh, we didn't do domain and range yet. Domain. We weren't done. X such that X can't be what?
0.
No.
5.
3. Vertical asymptote domain. Range. Y such that y cannot equal
3. Right?
No, 2.
2.
2. Okay.
How do you get two different things now?
Because one's vertical and one's horizontal. Okay. Are my y's ever going to equal my horizontal asymptote? No. Now, when we get into goofier ones, it will, and that's why we quit looking at it. Because we will get graphing things that look like this.
I know how to do the work part, not the graphing part.
Okay, we'll get there. It's a learning process. You are not supposed to know after one day. So, I don't want to do that. Okay, go back here. Okay, they want you to look at it like this, and I'm not going to worry about it. So I don't want to do that. Do we want to do one more?
No.
No?
Not really.
Okay, then you're going to be on your own, and I want to hear tomorrow whining.
Can you do
Wait a
one more,
minute.
please?
Yes, we can do another one.
Can I start my homework?
Okay, how can you start your homework if you don't understand what's going on?
I just don't get the graph.
I agree with Riley. That one looks confusing.
What one?
The one with the H and the K.
The H in the cage is left, the right, the up, down. We're not going to do anything with that. That's just, remember when you did left, right, up, down with quadratics? That's all it is. I'm trying to get a blank screen here, guys. Okay. So let's write this problem down, and then I'll switch to my blank screen. So 1 over x plus 2 minus 4. 1 over x plus 2 minus 4.
Can I start myself?
Yeah. I don't know. Okay, so I don't know what it was called. I'm just going to call it y. Oh, it's g of x. Okay. So my common, I have to get a common denominator, yes? So my common denominator is going to be the x plus 2. So that means I have to multiply 4 by what? X plus 2. So I have g of x equals 1 minus 4x minus 8 over x plus 2. So negative 4x minus 7 over x plus 2. Okay, if you just want to watch, it's perfectly fine. Okay, then we did x-intercept. Yes? X-intercept was the numerator equal to 0. So I'm going to add 7 and divide by 4, negative 4, and get negative 7/4, 0.
Wait.
Okay, vertical asymptote is the denominator. And when I'm doing this, I'm doing what, guys? I'm using this, yes? So x plus 2 equals 0. So x equals negative 2. You subtract 2 over. Then horizontal asymptote. So I compare the degrees. What is the degree of the numerator? What's the degree right here?
0.
Nope. If there's an x there, it's 1. If there's not an x, then it's 0. So the degree of the numerator is 1. What is the degree of the denominator? 1. So 1 equals 1. So the leading coefficient over the leading coefficient, which is negative 4 over 1, which is negative 4. That is so not straight.
I
have messages in the office
Right,
for
yes,
Addie
yes,
Young,
right.
Okay,
Natalie.
so I have a vertical asymptote at -2.
Reminder, get your yearbook.
A horizontal at
So
-4.
that the price will go up $10. Right now it's $35. It'll be
And then
$45.
x-intercept at -7.4. So like that's almost 2, isn't it? Because 8 divided by 4 is 2. So almost 2. So it's really, really close.
There's a junior class meeting today during
To 2,
IEP,
-2.
and that will be a Mrs. Mix,
It's on that side,
not
right?
the media center.
Okay,
It will be a
so
Mrs.
this
Mix.
graph, are there
Please
any
check into your
x-intercepts
IEP first,
on this
and
side of the
then
graph
report
right here?
to your-
No.
No, so it can't be there. It has to be where?
Another.
Down here. It has to be down there.
Can you use? Wait, can you not use the other one since there's no?
I'm not even there yet. I just did right there. There is no x-intercept. The graph cannot be here. Now, there is an x-intercept. Do I have to go through an x-intercept? Yes. So it goes right here and then shoots over, and it can't go through that horizontal asymptote, can it? And goes like that. So our domain. Domain comes from our vertical asymptote.
-2.
So x such that x cannot equal -2. Range comes from what asymptote?
The vertical or horizontal.
Horizontal. So y such that y cannot equal -4. Now again, that's only on these basic ones that we won't look at range later on, okay? Because when you have graphs that have different chunks, usually the range is all real numbers. It's just where you are at. You can put that in your calculator, and I would assume you would get something similar to that.